Hello students, welcome back. So we are doing logarithms exercise 8 from ICSE book of class 9, isn't it? And we have completed all the questions of exercise 8a and exercise 8b, okay? And today we are ready to start exercise 8c. So let's begin. This is exercise 8c and question number 1 of 8c, okay? I have already copied sub number 1 and sub number 2. We will solve each and every questions of exercise 8c also, so stay connected, okay? So this is question number 1. Condition is if log 8 to the base 10 equals to 0.90, find the value of log 4 to the base 10, and log 32, base is not mentioned, means base is 10, okay? If the base is not given, we must understand the base is 10. So let us solve this given condition. We will use this first. Since we know that this is given, okay, log 8 to the base 10 equals to 0.90, or log 8 can be written as 2 cubed, okay, to the base 10 equals to 0.90, or 2 cubed means 8, isn't it? So instead of 8 I wrote 2 cubed. This 3 can be brought in the front, okay? 3 log 2 to the base 10 equals to 0.90, isn't it? Or we keep log 2 in the left hand side and take this 3 by the cross multiplication to the denominator of right hand side. This 3 goes to the denominator 3, okay? Now let us cancel this. 3 1s are 3, 3 3s are 9, 0, okay? 0.30. Therefore log 2, the value of log 2 to the base 10 equals to 0.30, isn't it? So we found this. Now we will convert this and this in the form of log 2, and we will put the value of log 2 as 0.30 to find this value, okay, value of this numbers. Okay, now let us do log 4. Log 4 means log 2 squared to the base 10, isn't it? So this 2 can be brought in the front, 2 log 2 to the base 10, or this 2 we write as it is, and log 2 to the base 10 means log 2 to the base 10 means 0.30, isn't it? So we write the value of log 2 to the base 10, that is 0.30. Now we will multiply this. 2 zeros are 0, 2 threes are 6, decimal point comes here, 2 zeros are 0, okay? The answer is 0.60, 0.6, okay? This 0 has no value, so 0.6 is the answer. Log 4 to the base 10 means 0.6. Now we will solve this question as well. So log root under 32 means log 32 to the base power 1 upon 2, isn't it? 1 upon 2, okay, not 1 upon 12, 1 upon 2. Root means 1 upon 2, isn't it? Now we write this 1 upon 2 in the front, 1 upon 2 log 32 means 2 to the power 5, isn't it? 2 into 2, 4, 4 into 2, 8, 8 into 2, 16 into 2, 32. 1, 2, 3, 4, 5. 2 multiplied 5 times gives us 32. 1, 2, 3, 4, 5. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. 32 means 2 to the power 5, okay? So this is 1 upon 2 log 2 to the power 5, so 5 comes in the front, so 5 1s are 5 upon 2 into log 2 to the base 10. When base is not given, we must understand the base is 10, okay? So now we put the value of log 2 to the base 10. This 5 upon 2 we write as it is. Now log 2 to the base 10 means 0.30, isn't it? So into 0.30. Now we cancel this. 2 1s are 2, decimal point we should not forget, so we put decimal point here. 2 1s are 2, 3, isn't it? 1 remains. 2 1s are 2, 3, 1 remains. Now goes here, it becomes 10. 2 5s are 10. So 5 into 0.15 or 0.15, you can say 0.15. So 5 5s are 25, 5 1s are 5, 6, 7, 5 zeros are 0. Decimal point before 2 digits, so we put a decimal point before 2 digit. So this is the answer. 0.75 is the answer for question number 2. Okay, now let us do question number 3. Question number 3 of question number 1. Okay, this is question number 3. Condition is, if log 8 to the base 10 is 0.90, then we are asked to find the value of log 0.125. What we do is, we first convert this into log 2 form, and then we will put the value of log 2, which we have already found, 0.30, and then we can find the value of this number, isn't it? So let's begin. So log 0.125 means log 0.125. okay, we remove the decimal point and we put 3 zeros in the denominator. There is a decimal point before 3 digits here, 1 2 3, so we remove the decimal point and introduce 3 zeros in the denominator. Okay, so I hope you got this. This means log 125 means 5 cubed, isn't it? 1000 means 10 cubed. Okay, 5 upon 10 whole cubed, isn't it? 5 upon 10 whole cubed. Are you getting me? 5 cubed is 5 into 5 into 5. This gives us 1 to 5. 1 to 5 can be written as 5 cubed. And 1000 means 10 into 10 into 10. When you multiply 10 3 times, you get 1000, isn't it? So this cube is for both the numbers, numerator and denominator. Okay, so 5 cube means 1 to 5, 10 cube means 1000. Now what I do is 5 ones are 5, 5 twos are 10. Okay, so this 3 comes in the front, 3 log 1 upon 2. Here we have 1, in the denominator we have 2, 5 ones are 5, 5 twos are 10. So 3 log 1 upon 2. So this is actually 3 log m upon n. This means log m minus log n, isn't it? Log m upon n means log m minus log n. So 3 into log 1 means 3 log 1 minus 3 into log 2 means 3 log 2. Okay, now log 1 to any base. Okay, log, here we have base 10 because base is not given here, so we must understand the base is 10. So if the base is 10 or whatever be the number, let the number be x, whatever be the base, if log 1 to any base, then the value is always 0. Okay, the value is always 0. Log 1 to any base means 0. So 3 into log 1 means 0, 3 into 0 minus 3 we write as it is. Log 2 means we have the value of log 2 here, log 2 to the base 10. Log 2 means base is always 10, so log 2 to the base 10 is 0.30. 0.30. Now 3 zeros are 0 minus 3 zeros are 0, 3 threes are 9, point, we write point here, 3 zeros are 0. Now let me continue here. Okay, so 0 minus 0.90 means minus 0.90, isn't it? This minus sign is for this number, so minus 0.90. This is the answer for question number 3 of 1. I hope you got this. Now let us move on to the next question. Question number 2. This question is pretty similar to the previous question, isn't it? So if log 27 equals to 1.431, this is the given condition. Find the value of log 9, question number 1, and question number 2 is log 300. Okay, so the given condition is log 27 is 1.31. So let us do this. First we will simplify this. Since given condition is log 27 equals to 1.431, or you can write this as log 27 means 3 cubed, 3 cubed means 27, 3 threes are 9, 9 threes are 27, isn't it? Equals to 1.431, or this 3 you can write here in the front, log 3 equals to 1.431, or log 3 equals to, this 3 goes to the denominator by cross multiplication. Okay, 1.431 divided by this 3 comes here. So 3 ones are 3, 3 threes are 9, 3 fours are 12, isn't it? 13, 14, isn't it? So decimal point, we must not forget this. We put this decimal point here. 3 4s are 12, 13, 14, 2 in hand, 23, 3 7s are 21, 22, 23, 2 in hand, 3 7s are 21. So therefore we have log 3 equals to 0.477. Okay, so we found the value of log 3. Now we will convert this log 9 into the form of log 3, and then we'll find the value of log 9. Okay, so let's begin. Log 9 means log 3 squared. Okay, now you bring now you bring this 2 here. 2 log 3, this gives us 2. Log 3 means the value of log 3 is 0.477. So you write 0.477 instead of log 3. So we multiply with 2. 2 7s are 14, 4, 1 in hand, 2 7s are 14, plus 1 15, 2 4s are 8, plus 1 9. This decimal point we write here, 2 zeros are 0. So the value of log 9 is 0.954. Okay, so this is the answer for question number 1 of 2. Now let us solve this. So this is log 300, isn't it? This means log 3 into 100. 3 into 100 gives us 300. Log 3 into 100 is 300. 3 into 100 means 300. So log m into n means log m plus log n. Okay, so this is log 3 plus log 10 square, isn't it? 10 tens are 100. So this is log 3 plus this 2 comes in the front, 2 log 10. So this is log 3. Log 3 means we have the value of log 3, 0.477. 0.477 is log 3 plus 2 log 10 to the base 10. Base is not given, means base is 10. Log 10 to the base 10 is 1, isn't it? So 2 into 1. Now 2 1s are 2. 2 plus this. 2 1s are 2. 2 plus 0.477 is 2.477. Okay, so this is the answer for question number 2. I hope you got this. Now let us move on to the next question. Okay, now let us do question number 3. Log a to the base 10 equals to b. Find 10 to the power 3b minus 2 in terms of a. So we are asked to find this in terms of a, and the condition is log a to the base 10 is b. Okay. Since the given condition is log a to the base 10 equals to b, isn't it? So this is a logarithmic equation, isn't it? So we will convert this equation to exponential form. How do we do that? This 10 is base, so we write base here. This b comes as power equals to a goes to the right hand side. This is how we convert logarithmic equation to exponential form. Okay, now we need 3b, isn't it? So cubing both sides. Cubing both sides. So 10b whole cube equals to a cube. Cubing both sides. 10b whole cube means 10 to the power 3b. b into 3 is 3b equals to a cube. Now we need minus 2, isn't it? So dividing both sides by 100. Dividing both sides by, let me continue here. Okay, dividing both sides by 100. So 10 to the power 3b upon 100 equals to a cube upon 100. So this gives us, or 10 to the power 3b upon 10 squared, isn't it? 10 to the power 3b upon 10 squared. 10 squared means 100 equals to a cube upon 100. Or you can write this as 10 10 same base. This means this power goes to the numerator and subtracts. Okay, 10 to the power 3b minus 2 equals to a cube upon 100. You can write like this, or you can bring this 100 to the numerator and write 10 to the power minus 2. Both are correct. Okay, you can write this as like this: 10 to the power 3b minus 2 equals to a cube upon 100. Or you can do this, whichever way you write, both are correct. So 10 to the power 3b minus 2 is 10 to the power 3b minus 2 is a cube by 100, or a cube into 10 to the power minus 2. I hope you got this. Now let us do the next question. If log x to the base 5 equals to y, this is the given equation. Okay, and we are asked to find the value of this 5 to the power 2y plus 3 in terms of x. Okay, so let's do this. Since the given condition is log x to the base 5 equals to y, isn't it? Base is 5, or you can write this base, we convert this logarithmic equation to exponential form. Okay, this base is 5 to the power y equals to this x goes to the right hand side, isn't it? So log x to the base 5 equals to y can be written as 5 to the power y equals to x. Now what we need is 2y, isn't it? So we square this equation, squaring both sides, squaring both sides. Okay, so 5 squared means 2y, okay, equals to x squared. 5 squared, y was already there, we write y, x squared, squaring both sides. Now we need plus 3, isn't it? So multiplying both sides by 5 cube. Okay, multiplying both sides by 5 cube. So 5 to the power 2y into 5 cube equals to x square into 5 cube. Or since the bases are equal, you can add the power. Okay, 5 to the power 2y plus 3 equals to 5 cube means 125, isn't it? 5 5s are 25, 25 5s are 125 into x square. So 5 to the power 2y plus 3, we were asked to find the value of 5 to the power 2y plus 3, and the value is 125 x square. Okay, so this is the answer, 125 x square. Now let us do the next question. Okay, now let us do question number 1 of 5. Given log m to the base 3 equals to x and log n to the base 3 equals to y. Okay, so we are going to use this only because we are asked to find 3 to the power 2x minus 3 in terms of m. We have here, so we are going to use this equation only for this question. Okay, for the next question of the same number 5, this equation also should be used. Okay, now this one, since condition is log m to the base 3 equals to x, isn't it? So we change this into exponential form, or 3 is base, this x comes here as power, equals to this m goes to the right hand side, isn't it? Now we need 2x, that means we must square, isn't it? So squaring both sides, 3 squared, okay, x was already there, we write x here, equals to m squared, squaring both sides. Now we need minus 3, isn't it? So dividing both sides by 3 cube, okay, dividing both sides by 27, dividing both sides by 27. 27 means 3 cubed, isn't it? So let me continue this here. 3 to the power 2x, or 3 to the power 2x upon 27, dividing both sides by 27, okay, equals to m square upon 27. Now, or 3 to the power 2x upon 27 means 3 cubed, 3 3s are 9, 9 3s are 27, isn't it? Equals to m squared upon 27 we write as it is. Okay, now we bring this 3 to the numerator, sign of the power changes to -3, so same base means this power subtracts from here, isn't it? So we have learned this in laws of indices. If you don't know this, please check out the video for laws of indices chapter 7. Each and every questions of chapter 7 has been done. Okay, check out the playlist. So 3 and 3 bases are equal, that means power gets subtracted because this is in the denominator. 2x minus 3 equals to m square upon 27. So we were asked to find the value of 3 to the power 2x minus 3, 3 to the power 2x minus 3, that is m square upon 27. Okay, now let us do question number 2 of 5. Okay, now let us do question number 2 of 5. Write down the value of 3 to the power 1 minus 2y plus 3x in terms of m and n. So the given condition is log m to the base 3 equals to x and log n to the base 3 equals to y. So we are asked to find the value of log this term. Okay, we are asked to find the value of this term in terms of m and n. So let's do this. So to solve this question, we need to have a very clear knowledge of laws of indices, and if you do not understand any part of this question, okay, while solving the problem, please look back. I have already solved each and every question of chapter 7 laws of indices. You can find there the playlist. Okay, watch that video and come back to this topic again. So let's begin. Since the given condition is log m to the base 3 equals to x, isn't it? So we know that this is a logarithmic equation. We will convert this into exponential form. Okay, 3 is the base here, we write 3 here, this x comes here as power, equals to m goes to the right hand side. So we need 3x here. This means we are going to cube this. Okay, cubing both sides, cubing both sides, so 3 cubed x was already there, so I cubed 3, means m also should be cubed. Okay, cubing both sides, like squaring both sides, we can cube both sides. 3x was there, now I cubed 3 and I cubed m. 3 to the power 3x equals to m cube. This is equation 1. Okay, now we use the second term that is, the second condition is since log n to the base 3 equals to y, isn't it? Or this is also a logarithmic equation. We will convert this into exponential form. 3 is the base here, 3, this y comes here as power, okay, equals to this n goes to the right hand side. 3 to the power y equals to n. Now we need 1 minus 2y, isn't it? 1 minus 2y. So we have, or 3 to the power y equals to n. Okay, 3 to the power y equals to n. We need 1, power 1, isn't it? So multiplying both sides by 3, both sides by 3, I am multiplying both sides of this equation by 3. So that means 3 into 3 to the power y, so n into 3. Now bases are equal, power should be added. So 3 to the power 1 plus y, or y plus 1. You can write y plus 1 or 1 plus y, same thing. This 3 has power 1. So when you multiply the number having equal base, then their powers will be added. 1 plus y equals to n into 3 means 3n. Okay, now we need minus 2y, isn't it? But we have plus y. So what we do is dividing both sides by 3 to the power 3y. Okay, 3 to the power 3y, dividing both sides by 3 to the power 3y. Or we have 3 to the power 1 plus y in the left hand side upon 3 to the power 3y equals to 3 to the power 3n divided by 3 to the power 3y, isn't it? So this can be written as 3 1 plus, since 3 and 3 bases are equal, this 3 and this 3, so 1 plus we have y, so this plus 3y goes to the numerator and subtracts minus 3y, isn't it? Minus 3y equals to 3n upon 3 to the power 3y means 3y whole cubed, 3 into y, isn't it? Y into 3, same thing, 3y to the power 3, 3y, 3 to the power y whole cubed, okay? This is not 3y, 3 to the power y whole cubed. Y into 3 becomes 3y. Now, 3 to the power 1 plus y minus 3y is minus 2y, isn't it? Plus y minus 3y, opposite sign, 3y minus y is 2y, sign of greater number comes minus 2y, sorry, equals to 3n upon 3 to the power y. 3 to the power y means we have 3 to the power y means n, isn't it? The value of 3 to the power y is n. So we put n and we have cube, okay? So let me continue this sum here. Now we need plus 3x, isn't it? So we multiply both sides by 3 to the power 3x. multiplying both sides by 3 to the power 3x. Now we have 3 into 1 minus 2y, 3 to the power 1 minus 2y, power 1 minus 2y into 3 to the power 3x equals to, this we already have, 3 to the power 1 minus 2y into 3 to the power 3x. Now we need to multiply this also. 3n into 3 to the power 3x, isn't it? 3x whole upon n cube, okay? So this n cubed and n can be cancelled, isn't it? So here we have a square, here this n is gone. So 3 into 3 to the power 3x upon n square, isn't it? So let me continue here, okay? So same base 3 and 3 powers will be added. 3 to the power 1 minus 2y plus 3x equals to 3 to the power 3x. 3 into 3 to the power 3x means m cube. This 3 remains here as it is. 3 to the power 3x means m cube from 1. 3 to the power 3x, 3 to the power 3x means m cube. So this 3 is this 3, okay? 3 to the power 3x means m cube divided by n square. So we were asked to find the value of 3 raised to power 1 minus 2y plus 3x, and the answer is 3m square by n square. Sorry, 3m cube by n square, okay? I hope you got this. Not a tricky one, but bit lengthy, isn't it? But you need to have a very clear knowledge of laws of indices, okay? So please go back and look the playlist of laws of indices, chapter 7. Let us do question number 3 of 5. Given conditions are log m to the base 3 equals to x, okay, and log n to the base 3 equals to y, and the third condition is 2 log a to the base 3 equals to 5x minus 3y. So we are asked to find a in terms of m and n, okay? So let's do this. Since the given condition log m to the base 3 equals to x, isn't it? So 3, we change this into exponential form, okay? 3 to the power x equals to m, isn't it? So like squaring both sides, cubing both sides, we need 5, isn't it? 5x, isn't it? So we power 5 by both sides, okay? Powering by 5 both sides, or 3 to the power 5x equals to m to the power 5. We put power 5 both sides. So this is equation 1. And equation 2, log n to the base 3 equals to y, and log n to the base 3 equals to y, isn't it? Or we change this also into exponential form. 3 to the power y equals to n, isn't it? Now we need 3y, so cubing both sides. 3 to the power 3y equals to n, 3n, isn't it? N cube, okay. Cubing, isn't cubing? 3 to the power 3y equals to n cube, cubing both sides. Power is 3. 3 to the power y was already there, we put 3 cubed, and n was there, so we cubed n also. This is equation 2, okay. Now we will use the third condition, 2 log a to the base 3 equals to 5x minus 3y. Since 2 log a to the base 3 equals to 5x minus 3y, or what we do is log a to the base 3, this 2 goes to power, isn't it, equals to 5x minus 3y, or we change this logarithmic equation to exponential form, okay. 3 is power, okay, 5x minus 3y, 5x minus 3y equals to a square. This 3 remains here as base, this comes here as power, a square goes to the right hand side. Or 3 to the power 5x minus 3y means 3 to the power 3y, isn't it? If I bring this 3 to the power 3y to the numerator, sign of the power changes to minus 3y, same base, power subtracts, isn't it? This can be written in this form, okay. So this is a square. Or 3 to the power 5x is, so let me write this a square here, okay. A square equals to 3 to the power 5x means 3 to the power 5x means m to the power 5, m to the power 5 upon 3 to the power 3y means 3 to the power 3y means n cube, n cube. This is from 1 and 2, isn't it? From equation 1 and 2, okay. Or this square, if you take to the right hand side, becomes a square root, isn't it? A square becomes root m to the power 5 upon n cube, okay. So this is the answer for question number 3, okay. We were asked to find the value of a, and the value of a is root under m to the power 5 by n cube, okay. So this was for today. Thank you so much, and stay connected. I'll upload the rest of the questions in the next video, okay. Thank you.